Hi guys, Mr. Antonucci here, and we are in our last and final video for section 6.5, indefinite integral method of substitution. Our target is I can integrate even and odd functions. So, turns out that integrals of even and odd functions sometimes can be simplified using symmetry. So, if we look here, we have an even function right here, okay? If f is even and you're integrating over a symmetric interval, so negative a to positive a, since the graph is a reflection of itself, it's the same as if you did twice the integral from 0 to a because of the symmetry. Okay? Now, if the function is odd and the function is symmetric over the interval, or you're doing a symmetric interval, so from negative a to a, the integral is going to cancel out because it's a rotational symmetry of 180 degrees. So this region above is the same size as the region below here, but this one in green gets counted as negative. This one gets counted as positive. So they cancel each other out. Okay, so here's our theorem. If a function is continuous on a closed interval, negative a to a, if f is an even function, then the definite integral from negative a to a is equal to 2 times the integral from 0 to a. And why that's advantageous is because lots of times if one of your limits is 0, it's a lot easier to evaluate, especially if you go from having to plug in a negative number to plugging in 0. But if the function is odd, then that same definite integral is equal to 0, and you can think of that as the regions cancel each other out. So if we look at our example here, we want to integrate these two um, functions. And I will say that integrating even and odd functions is not specifically tested on the AP exam. However, it can be an aid to helping with integration and simplify things a little bit. So to test if a function is even or odd, we take the related function here, f of x equals x to the 7th minus 4x cubed plus x, and we plug in negative x. So negative x to the 7th minus 4 times negative x cubed plus negative x. And then you simplify that. Well, since you have a negative number to an odd power, that is going to give you the opposite to that odd power. So in other words, you would have the opposite of x to the 7th plus 4x to the 3rd minus x, which is equal to the opposite of x to the 7th minus 4x cubed plus x, which equals the opposite of f of x. So in other words, if f of negative x equals negative f of x, then your function is odd. And then this integral is just going to be 0. Okay? For this one, f of x is equal to x to the 4th minus x squared plus 3. F of negative x is equal to negative x to the 4th minus negative x squared plus 3. Now, since you have a negative raised to an even power, it's going to simplify to a positive raised to that even power. So this is just going to be x to the 4th minus x squared plus 3, which is equal to f of x. So if you have the opposite, f of the opposite of x equaling the original function, then it's going to be an even function. That basically says when you plug in the negative x, it's going to give you the same answer as the positive x, which is an even function. So this is going to be equal to 2 times the integral from 0 to 2 of x to the 4th minus x squared plus 3 dx, which is 2 times x to the 5th over 5 minus x to the 3rd over 3 plus 3x evaluated from 0 to 2. So that's just going to be 2 times, if you plug in 2, you would get 32 fifths minus 8/3 plus 6 minus everything evaluated at 0 is going to be 0. So if you get a common denominator, add them all up, multiply by 2, you would get 292/15. Okay, so have one more problem here. If f of x equals -3 to integral, excuse me, if you have the integral from -3 to 3 of x squared plus k dx equals 24, find the value of k. Well, since x squared plus k is even, I can think of this as 2 times the integral from 0 to 3 of x squared plus k dx equals 24. Now, this is a little bit different because we have an unknown value here, k, that we got to solve for. Well, first thing is if I use this even odd property, I can cancel the 2 with the 24 and make that 12. So, anti-differentiating, you'd have x cubed over 3, and k stands for a constant, so the antiderivative of k with respect to x would be kx, not k squared over 2, because you're thinking of k as a constant and letting x be the variable here. Okay, so you plug this in from 0 to 3 and set that equal to 12. So I would have, if you plug in 3, 3 cubed is 27, divided by 3 is 9, plus 3k. And if you plug in 0, it's just going to end up being minus 0 equals 12 again. All right. So you have 9 plus 3k equals 12, 3k equals 3, and k equals 1. All right. Well, that's about it for this section, guys. Actually, I have one more I want to show you because this kind of problem often comes up on the AP exam. And if we're using properties of integrals, so this says f is an even function and 0 to 2 of f of x equals -6, -5 to 0 of f of x equals 8. Find the integral from 2 to 5. So we got a couple properties going on here. So the integral from 2 to 5 of f of x dx equals the integral from 2 to 0 of f of x dx plus the integral from 0 to 5 f of x dx. Now the integral from 2 to 0 is the same as the opposite of the integral from 0 to 2 of f of x dx, which is going to be the opposite of -6. And since f is even, the integral from 0 to 5 is going to be equal to the integral from 0 to -5. But they gave us the integral from -5 to 0 and said that that was equal to 8. Since the limits are switched, no, we're good there. It's going to be equal to 8. Limits are not switched because it's an even interval. So if you go from 0 to 5, that's the same as going from -5 to 0. Okay? So that's going to be 8. So you have 6 plus 8. Our answer would be 14. All right, guys, now we're done. Hope that was helpful to you. Again, reach out if you have any questions. Take care.